When you are checking on the nature of the paper, the nature of the paper is that it comprises of section A, which is made up of question number 1 and question number 2. And each question, as usual, it's 60 marks. A full question is be 60 marks. So the first question will be based on the atmosphere, and the second question will be based on geomorphology. And then we have our geographical skills and techniques, which is map work out of 30 marks. So that is the expected structure of the June paper. It will have those three aspects of covering term 1 work, which is the atmosphere, and also covering term 2 work, which is geomorphology, and inclusive of geographical skills and techniques out of 30 marks. Right, let's go to our questions. Right, we are having a set of multiple choice questions. Remember, when you're answering multiple choice questions, we can never have 2 correct answers. So you cannot write a response like B or C, or you cannot write D or A. You just write one response. There is only one correct response for multiple choice questions. Right, let's start with number 1, an example of a constant gas. Remember, when you're looking at the gases in the atmosphere, they are comprised of what we call the variable gases and the constant gases. Some gases are variable, meaning to say they change, while some are constant. We have variable gases and we have constant gases. Right, what we call a variable, we are saying they change in terms of their percentage in the atmosphere, and what we call constant, they remain the same. So among us, this, we have some gases which are variable and some which are constant. Our correct response is A. Nitrogen is the one which is constant. Carbon dioxide, hydrogen, and water vapor, they vary from place to place. They are not, they don't remain the same, or they don't maintain the same percentage. Right, then we go to question number 1.12. These lines join places with equal air pressure. Right, when you're looking at these lines on the map, we're looking at reading and interpreting our synoptic map. Right, we have got those lines that we see when we are looking at synoptic weather maps, and they will be having some values. Let's say maybe this one is a return 10, 20. This will be HPA. And maybe this is 10, 24. And maybe this is 10, 28. These are the lines that we refer to when we are reading our synoptic weather maps. And these lines, basically, they show the different, they connect places of the same pressure. What do we call them? Right, we call them isobars. They are called isobars. That's the correct response for that particular question. Right, then we'll move on to question number 1.13. These chemical compounds are responsible for the breakdown of the ozone layer. Remember, we talked about ozone depletion. What causes ozone depletion, or what is responsible for the damage of the ozone layer? Right, the correct response is the chlorofluorocarbons, or which we call the CFCs. These are the gases responsible for the damage of our ozone layer. Right, then we go to the next question. It's number 1.14. It says, a transfer of heat through the conduct of air molecules. We are saying air molecules are getting into contact and they tend to give each other heat. What kind of heat transfer is done through conduct? The term suggests they are conducting each other, as in conduction. So that is the correct response. Correct response is conduction. Through conduction, the air molecules come into contact and they pass each other a heat, so that the heat is transferred from one to the other. Right, then number 115, an instrument used to measure rainfall. What instrument is used to measure rainfall? I think also the term suggests we're talking about rain, and we're having an instrument with rain here. So that is basically our correct response. It's a rain gauge. And remember, our rain gauge is uses millimeters to measure the amount of rainfall received in a given area. That is basically the correct response. Right, we move on to the next question. Inland climate, which results in a big range between minimum and maximum temperature. Right, we are looking at inland here. We are saying we are looking at places which are far away from the seas and the oceans. They are truly inland. Like, for example, if you talk of Gauteng province, it's an inland place. It is far away from the ocean or the sea. And we are talking about a big range here. The range, we are looking at the difference between maximum temperature and minimum temperature. We are saying there's a wide gap between the maximum and the minimum that is possibly recorded in those places. What kind of a climatic situation is that? We understand it's inland, and when we're talking of inland, it means automatically maritime is out. So it's what we call the continental climate. Continental in the sense that we are looking at climate over the continent. So continental climate is the one that is correct for that matter. Maritime, it refers to water. Then the subtropical climate region, we know the subtropical, we are looking at the places which are closer to the equator, either 30 degrees south or 30 degrees north of the equator. Right, I will move on to the next question, which is number 7. Right, number 7, it says, the following are greenhouse gases. We want to pick out greenhouse gases from the combination which is given in that illustration of gases. We have number 1, carbon dioxide, we have argon, we have water vapor, and we have nitrogen. So if you are trying to analyze, we are very sure that carbon dioxide is a greenhouse gas. And we can also check on water vapor as another gas. So our correct response, it means it must have item number 1 and item number 3, which gives us the correct response as B. Right, so basically that is how you can attempt your multiple choice questions, and you must try to maximize on the multiple choice section because those are lower order questions and the responses will be provided. And also the other unfortunate thing that most learners tend to give themselves a disadvantage is not providing a response to a question which they find difficult. If you don't attempt a question, it means you are disadvantaging yourself. If it's multiple choice, responses are already provided. You must not leave a blank space. At least there is response A to D. You must just at least give a response and not just leave blank spaces. That is going to disadvantage because automatically you have lost that mark that you did not try to answer. You have lost the mark because you did not attempt the question. Right, we move on to analyze this other illustration here. It's a very important illustration that learners must always try to memorize the structure, the layers of the atmosphere, starting from the lowest layer until we get to the last layer of the atmosphere. Right, so what you must understand here, if you are reading your graph, you must understand the changes in temperature versus the changes in height which is taking place. Like in the troposphere here, we are seeing that our temperature profile is ultimately negative. The first layer, the higher we go, this is our temperatures. You are seeing that our temperatures are declining along this line here. As height is increasing on the vertical axis, our temperature is declining on the horizontal axis. Then we have a pause here, and then we see our temperature profile going positive again in the next layer. Then we have a pause, and then it goes again negative to extreme cold temperatures of around minus 100 degrees Celsius. Then we have a pause, and then we have a positive temperature profile in the last layer. So we want to answer the questions quickly. All right. Here, you must follow instructions. Again, if you get a question like this one, you must follow instructions. If the question is saying choose the correct letter from A to D, You must not write the names of the layers. You must just write a response based on the letter which is provided. Even though it will be marked correctly, but your chances of losing marks will be very high, because if you miss the layer or you mismatch the layers, then your responses are going to be wrong. You must just try to find out the response from the given letters from A to D. Right. All weather takes place in this layer. Which layer do we find where the process is taking place? It's A, right? And the densest layer of the atmosphere, the densest layer is also A. Temperature inversion takes place. Temperature inversion, I think you must understand what we call temperature inversion. It's a situation whereby we have an increase in temperature with an increase in height. So if we check here, it's positive. So in layer B, this layer is found above the tropopause. A layer found above the tropopause. It's B. From troposphere, which is layer A, we go to the tropopause, which is the boundary. Then we go to layer B. Right. This layer is found below the thermosphere. Below the thermosphere, our correct response is C. Remember, the thermosphere is the one at D, which is the last layer here where there is positive temperature profile. So C is the one which is below. Then we go to aeroplanes fly in this layer to avoid turbulence, that is B. Right, they slightly fly above the layer where weather takes place, which is above layer A. So in layer B, 127, this layer is the highest amount of water vapor and oxygen. The highest amount, we find it in the troposphere, which is our layer A. Then lastly, temperature decreases in height between A and temperature decreases with height. A, we saw that the temperature profile here is negative. In which other layer do we have a negative profile? Here in C, you are seeing that the temperature is declining with height. So the correct response for that matter is our letter C. Right, those are the responses to question number 1.2. All right, we need to move on and look at the other coming questions and try to analyze and see how best we can attempt those questions, how we can figure out the correct responses. Right, this is an article on climate change. Right, you are referring to that article. We are not going to go through the whole article, but we are just going to highlight where we find responses or where it is relevant to our given question. Right. Define the concept climate change. We're supposed to define climate change. Right. When we're talking of climate change, we are looking at a change in the pattern. Right. We are saying here when the climate is changing, what is happening? There is a shift or a change in the pattern of climate. Which is happening across the world. So we are saying climate change basically refers to a change or it's a shift in the pattern of climate across the world. Our climatic conditions are deviating, they are changing. So that is a situation of climate change. They are shifting from the normal to the abnormal. We are having new climatic conditions across the world, which were not part of our global climatic conditions. Right. Then according to the article, what is the main contributor to climate change? According to this article here, what is the main contributor to this problem of climate change? Right. If we check through, you tend to find that in the text, whatever is being explained there is attributed to the human activities. Human activities, they do contribute towards climate change in a number of ways. People release greenhouse gases, do activities that contribute towards the release of greenhouse gases like carbon dioxide and methane in the atmosphere. And that results in global warming, actually. And that is contributing factor to climate change. Right. Let me move on to the next question. Name one gas from the article that causes climate change. The gases are indicated. They are there clearly indicated. It talks about carbon dioxide. It talks about methane. So basically, if you check on those two, they are the ones indicated in the text. Carbon dioxide and methane are the ones indicated in the article as the contributing gases to the problem of climate change. Right. Number 134 says, how did countries that attended the COP26 summit show commitment to reduce methane emissions? The countries that attended that summit on climate change, they showed commitment towards reducing their methane levels. Right. It talks here on the economies joined the global methane pledge to cut methane emission by 30%. So if we see here is where we are getting our sense of commitment from the text. What did the countries do? Right. So we are saying these countries, they showed commitment through signing global methane pledge. By signing a pledge, again, we are acknowledging that we are going to follow the principles of whatever we have agreed upon. We are going to be guided by the principles of what we have agreed upon. So countries that actually signed the pledge to show their commitment to was the reduction of their methane levels that they release because of the different activities that happen. Right. We move on to the next question. Suggest reasons why countries like Australia and other industrialized countries usually object or refuse to signing pledges such as the one in the article. We are looking at these countries, and they are the ones that contribute more towards the release of those gases, and they do not accept signing such pledges. So why is Australia, as an example, given such a blame of refusing to cooperate and signing such pledges? Right, you can say it is expensive. To reduce their carbon footprint. For these countries, it's very expensive. They are industrialized. They depend on the industries for their sustenance. They are heavily industrialized. So by signing pledges, it means they are dedicating themselves towards reducing industrial activities. So that comes with a cost on the side of the countries. So it's expensive for them to sign. Or we can also say it will affect their industrial activities. Definitely, if they are supposed to reduce their carbon footprint, it automatically means that they are supposed to also reduce their contribution of carbon footprint towards by their levels of industrialization or industrial activities. So it means they will be affected negatively. Or we can also blame that they don't want to be accountable, not want to be accountable. They don't want to be accountable for their carbon footprint. They know very well that they are the ones who contribute the highest carbon footprint, but they do not want to be accountable for such. That is why I tend to find that they tend to object signing of such pledges where countries commit themselves towards reduction of the levels of emissions. But for the developed countries, because they are heavily industrialized, it also implied that by signing the pledge, they are supposed to cut on their levels of production in industries, which comes at a cost, with a cost on their side, because their economies are relying on those industries. Right. We move on to the next question. The next question is, discuss the strategies that local municipalities um, can implement to reduce the heating of the atmosphere and the resultant climate change. Right. Municipalities, we can talk of, they can put in place strict laws to control air pollution, strict laws to control air pollution. They can implement and enact those laws to prevent and reduce the levels of air pollution, and also um, encourage use of public transport. Public transport will assist. If individuals are using their own private modes of transport, that is going to contribute more towards emissions. But if people use public transport like the trains and the buses, it will mean that the number of vehicles on the road is going to decrease, and ultimately we are going to have less emissions into the atmosphere. And also, we can encourage people to use green energy, encourage people to use cleaner source of energy, e.g. solar. It's also another way. Or the municipality can develop parks to help absorb carbon dioxide. They can also assist by developing parks where there's vegetation or vegetative cover, and ultimately the trees are going to absorb excess carbon dioxide in the atmosphere and give a lesser burden on the burden of heating, which is caused in the, which is a result of the greenhouse gases in the atmosphere. Right. So those are some of the strategies that the municipality can enact or can put in place as a measure to try and limit the level of heating of the atmosphere and apparently climate change. Right. Then we go to question number 1.4. Question number 1.4 is South Africa is a semi-arid country, limited water resources. It's basically an extract on rainfall in South Africa. Right. Name the type of climate experienced in Durban. Right. If we check there, we are looking at Durban as a city which is located here. We are seeing the location of Durban. Durban is located here. And we are having our Indian Ocean there. So what kind of climate is experienced at Durban? Here we said we have continental, which is inland. Like for example, here it's inland place. This one here, what kind of a climate is experienced? So the correct response for that one is a maritime climate. Durban experiences a maritime climate. The climatic conditions are influenced by its nearness to water, and that is going to control the climatic conditions there. They name the ocean currents that flow past Durban and Cape Town, respectively. Right. This question here, if it says respectively, if you do not want to label your places like Durban, what kind of ocean current, and Cape Town, make sure you present your responses in the right order of the question. You start with the Durban response, then you answer the Cape Town response. Because if you interchange the two, the question is saying respectively, meaning to say in that order. So if you don't label your towns or your cities, it automatically means the first response is for Durban and the second response is for Cape Town. So if you interchange the two, you get the answers wrong. So you must be very careful with that. Right. So the ocean current at Durban, the ocean current there is the warm Mozambique. It's the warm Mozambique current. It's the one that is experienced at Durban. Then if you also check at Cape Town, the Cape Town is influenced by the cold Benguela current. Those are the two currents that affect those two coastal cities of South Africa. It is the cold current along the Cape Town area, and it is the warm current on the side of the um, Indian Ocean. So it's clearly indicated there as suggested by the response that we have given there on tour. Right, we move on to the next question. The next question is talking about describe the average rainfall variation from the east to the west of the country. Describe the average rainfall variation from the east to the west of the country. How does water vary from the east going to the west? So if you check our east, this is our west of our indication, and this is our east. Our question is saying describe the variation of rainfall from the east to the west. So from the east here going to the west. The east we have greater than 800 millimeters. Then here is 250 going to 500. Here we are seeing is less than 250. So we are comparing these figures basically. Is it increasing or is it decreasing? Whereas we are moving in that direction. As you are moving in that direction. Right. Then the next question is saying the rainfall graph below shows that rainfall in Cape Town increases significantly in winter. With an aid of a well-labeled diagram, illustrate the type of rainfall experienced in Cape Town. Right. Basically, you must understand the types of rainfall that we have so that you're able to figure out how you are supposed to draw. Right. We have convectional rainfall. And then number 2, we have frontal. Then number 3, we have relief or orographic. Right. Convectional, this is mainly the type of rainfall which is caused by excessive heating during summer days, which leads to the creation of convectional currents. And with those convectional currents, there is evaporation that is going to happen. And with evaporation, the moisture is going to reach a dew point, is going to condense and form clouds that produce a rainfall, which is typically summer conditions in the interior. Then frontal is the one that is experienced around Cape Town, which happens in winter because of the movement of the cold front. Then we have relief. This is typical of rainfall which is experienced around Durban because of the Drakensberg Mountains. Right, there is uplifting, which happens as the warm moist air coming from the warm ocean current is forced to rise as it goes over the Drakensberg Mountains, relating to condensation at higher levels and ultimately the formation of clouds. So when you are looking at this is frontal rainfall for Cape Town in winter. So what you can simply do there is you draw your cold front, and then the clouds will form on this side, which is rain bearing, and also sometimes with some thunderstorms. And you indicate that this is your cold front. This is the cold front. If you can also add other labels, this is the cold sector, and this is a warm sector of the weather system. So basically what is important for you there to note is for you to draw the cold front and also indicate that rainfall is received on the other side, indicate a cloud, and also indicate precipitation that is going to be realized. That is basically frontal rainfall, right, which is part of the mid-latitude cyclone system. Right. Let's move on to the next one. In a paragraph of approximately 8 lines, discuss the economic and social impacts of the rainfall mentioned in question 1.4.4. What is the economic and social impact of that rainfall which is received over Cape Town during the winter season? Right. So when you're looking at the impacts, you are supposed to address economic and also social impacts. You cannot rely on one of the two. You are supposed to balance your discussion by highlighting on the social and also you highlight on economic. So your question must address the two, economic and social impacts. Right, if we check on economic impacts, we can talk of more money spent on medical care when people are sick. There are high chances that people will get sick because of the excessively cold conditions. It's raining and it's winter, it's cold, and the rainfall is bringing in more cold conditions. So it means people are going to spend more money on medical care when they get sick because of that situation. And also people loss of income for outdoor workers. Those who work outside, they can't go to work during the time of the rain because it will be raining heavily and it will be excessively cold. The conditions won't allow for someone to work out. So those who do manual jobs, who work outside, they cannot go to work, and as a result, they lose their income during that time. And also, people might need money to rebuild because need money to rebuild. This rainfall is destructive. It can destroy some infrastructure like buildings and other important infrastructures. So it comes with an expense of money which is supposed to be used to rebuild and to redevelop the destroyed infrastructure. And also, you can talk of the effect on tourism activities. Tourism is affected. Remember, tourism is a source of income for those employed in the sector of tourism and also in related industries to the tourism activities. Tourists cannot effectively visit the place when it's excessively cold. It's freezing and people cannot just go out doing fun activities during that time of the rainfall because in those days you tend to find that it will be snowing and people can't go do their tourist activities. So it represents a challenge in the loss of potential income, what was supposed to be reaped from tourism activities. So all those things, if you look at them, they are economic in nature. They have to do with making money and they have to do with a way of finding or making a life. Then we look at social effects or impacts. Social, we are saying the society, how are people affected as a society, the way of life of people, how are they affected by the rainfall in winter, which is usually experienced in Cape Town. Right. We are saying here there's a problem of spread of diseases because of cold weather. When there's cold weather, you tend to find that there is spread of some infectious diseases, like you can talk of the common cold, you can talk of flu, people are affected and the disease will spread amongst the people. That is a negative implication on the way of life of people. People are now sick because of the excessively cold conditions. And we can also talk of displacement of people. People can be displaced, especially people in low-lying areas. If the rainfall is too high, it means those areas are prone to flooding, and it also gives the need for evacuation of people from their areas. They have to be evacuated and they are displaced for the fear of flooding. And also, people might drown due to flooding, drowning, and loss of lives. Some people might be unfortunate to die in that heavy rainfall, and that is a negative implication on the life of people. So basically, if you check, we've addressed the social and we've also addressed the economic. We must not address one side. We must balance our discussion as we write the paragraph, address the economic impacts and also address the social impacts. Right. We move on to the next question, which is a question on a synoptic map. I think you're able now to read and interpret synoptic maps and figure out whatever weather element is represented by whichever symbol is used on the synoptic map. Right, we go to our questions. What is a synoptic map? Basically, when you are discussing a synoptic map, what is important there is you give it as a map that shows a summary. Synoptic, it means it summarizes. So it's a map that gives a summary of a day's weather. It summarizes all the weather elements of a given place on a particular day. Right, name the season represented on the synoptic map. Right, our season here, there are some things that we're going to check which will substantiate why we chose that season. And for this matter, our correct response is the summer season. Why are we saying it's summer? What are the indications on the map that give us a clue that this is a summer map? Right. There is this low pressure cell over the interior here. It happens as a result of intense heating, and that can only happen during the summer season, what we call the thermal law. Is caused by intensive heating during the summer season, where the ground is heated and it creates a low pressure as air is forced to uplift because of loss of density of the heated air molecules. Right. Then we also have the other evidence. If you check this weather system here, this is a cold front, which is part of a mid-latitude cyclone or an extratropical cyclone. So this, if you check here, it's very far away from further to the south. It's very far to the south. If this weather system was somewhere here, that will give us a clue that it's winter because it is going to affect the western coast of South Africa during the winter season. But this one won't affect, it's further to the south, which also suggests that it happens during summertime. We don't have cold fronts affecting the Western Cape area during the summer season. It's only happening during winter season. Right, that is the other evidence. And also, if you check the high pressure cells, they are also further to the south. These ones here, the high pressure cell, we are looking at this indicated H, and on the west is not very clear, but if you check, it's further to the south. These ones, we say they move latitudinally with changes in seasons. In winter, they will move further to the north, and in summer, they will be further to the south. So if you check this South Indian high pressure cell is further to the south, it also suggests that it's a map from the summer season. Right, we move on to the next question. Identify the high pressure A on the map south. This one here, we have mentioned this already. We said this one is the South Indian high pressure. It's on the east. And remember, on our east, that is where we have the Indian Ocean. On the west, we have the Atlantic. So this high pressure cell is called the South Atlantic high pressure cell. So you must give a specific name, not just say a high pressure, because we have several high pressures that exist. You must mention it by a specific name. It's the South Atlantic high pressure cell. Right. Then number 155, what is it saying? Number 1.55, it says name the lines marked C on the map. I think we've talked about that in the section of multiple choice. This is a synoptic weather map, and these lines are giving us or are joining places of the same air pressure. So basically, we call them the ISO bars. That's the correct response for number 155 is an ISO bar. They show areas with the same pressure. So they are isobars. Describe the weather in Durban by referring to the following. We want to check Durban and see how the weather conditions are like. We are summarizing this weather station here. Right, what is the air temperature between the two? This is 24 degrees Celsius, this is 21. The air temperature is the maximum or the bigger value of temperature on the map, which is 24. That is our air temperature. Is 24. And remember to put units of measurement. Our temperature is presented in degrees Celsius. And the dew point temperature is the minimum temperature, which is 21 degrees Celsius. Then the cloud cover, we figure it here. The shade, which is in this circle, the fraction of the shaded circle, that is the amount of cloud cover as a fraction of 8. So here it's fully shaded, which means it's 8 out of 8. Or which we can say is overcast. Right, then we go to wind speed. Where do we derive our wind speed? We derive our wind speed by looking at these feathers here. One full feather, it represents 10 knots and half. It means it's 5, so it's 1.5 here, which means our wind speed for that station is 10 plus 5, which is 15 knots. Then wind direction. We check our wind direction by looking at where this bar is pointing to. This bar here is the one that shows us the direction of the wind. And if we check there, where is it pointing? It is pointing towards the east or northeast. So it's east is correct, or you can say northeast. That is where the wind is coming from. Right. Then refer to the enlarged station model of Durban and explain why there is high possibilities of rainfall occurring. Why is it likely that we can have rainfall occurring here at Durban? The first obvious reason is about cloud cover here, which we have talked about. We have said there is overcast condition. The sky is fully cloud. So chances of rainfall are very high likely. There is overcast conditions. Then also the difference between the two, small difference between dew point and air temperature. It suggests that chances are high likely that it can rain because the difference in temperature between the maximum and the minimum there is too small. Right, so basically that is with our climate question. We have gone through the question and we've tried to highlight all important aspects and just try to figure out the justification of our answers to given questions. Right, what we need to do now is we need to move on to question number 2. Our question number 2 is a geomorphology question. Our geomorphology starts with a matching column question. Right, we are choosing the matching item either Y or Z from column B, which matches with the description in column A. Right, we'll quickly go through this. I think the types of rocks, you know them. We basically have the sedimentary rocks, which form from sediments. We have igneous rocks, which are rocks of volcanic origin. We have metamorphic rocks, which are made from a complete change of either igneous or sedimentary rocks which are exposed to great heat and pressure. Right. So we are going to look at the questions and give the right responses. This rock is formed when magma solidifies. This is an igneous rock, rocks of volcanic origin. Igneous dash form when lava flows on the surface. Right, that is an extrusion. Intrusion, it means inside. Extrusion, outside. So if the rock solidifies within the Earth's crust, it's an intrusion, and an extrusion, lava flows on the surface outside. Right, these are types of rocks that change their material composition due to immense pressure and temperature. We've talked about that. Those are metamorphic. Metamorphic from the word metamorphosis, which means change. It means these rocks were initially either sedimentary or they were igneous rocks, but they have gone through intensive heating and intensive pressure. Then they are forced to change their form to become a completely different type of rock. So that is a metamorphic rock. Then we go to number 214. Is the process whereby rocks break down into smaller pieces, that is automatically weathering. Then we move on to the next question. Dash are the main minerals found in oceanic crust. Which one is the oceanic crust? The continental crust is the Sahel. Then the oceanic crust is the Sima. So silicon and magnesium. Right. This is a characteristic of a sedimentary rock. What is the feature of a sedimentary rocks? Sedimentary rocks are stratified or they are layered. Remember, they are made from sediments of other rocks. So the sediments accumulate and accumulate over time, creating layers. And also remember that the rocks are weaker rocks, which can ultimately break easily or can crumble. Right. We move on to the next question, which is question number 217. This type of rock is easily eroded. Which one is easily eroded? An igneous or a sedimentary? Obviously, it's a sedimentary because it's made up of different sediments. It's a weaker rock. Igneous rocks are very hard and solid. Like you can talk of granite, you can talk of basalt. Those rocks are very hard because they come from the hot molten rock from volcanic activity. Right. That was the first part. Right, we move on to the next part. We need to analyze the next question and see how we can figure out the right responses for the next question. Right, it says, it gives us the internal structure of the Earth. It shows the different layers which make up our Earth. Right, we have to go straight to our questions. Right, the layers I understand maybe for clarity purposes, our layer D, this is the Earth's crust. Just for a quick labeling, this is actually our crust. And then we go on to our mantle. And then we go to our outer core. Then we have our inner core. And remember, we have the discontinuity here, which separates the crust from the mantle. The more discontinuity. Right. That does not, that is just a matter of reminding you or taking you back to the labeling of the internal structure of our Earth. But what matters here is us getting responses to our questions. This layer is broken into smaller segments called plates. Which layer is broken into smaller segments, which are called the plates? That is automatically the crust, which is D. Then this layer is the highest temperature. Where do we get the highest temperature? We get the highest temperature in C. Then we go on to is thicker beneath the continents but thinner beneath the oceans. Right. This is the crust, which is D again. This layer is in a molten state. The molten state is the mantle, which is B. Then tectonic plates float on this layer. It's also B, they float on the mantle. Then this layer is liquid due to high temperature. That is layer A. right? Topsoil is found in this layer. That is the crust. We find it in the layer B. Then separated by the mold from the mantle is B again. We talked about that. So those are the correct responses from question number 2.2. Right. We move on to the following question as we go through our discussion. Right. We have question number 2.3, which is basically based on plate tectonics and the East African Rift Valley. Right. Give the concept plate boundary. That is the question. The question is asking out us on what a plate boundary is. So in simple geographic terms, you can give a definition for a plate boundary as you can say it's a point where two plates come together. Two plates come together. That is basically the concept of a plate boundary. We are saying we are floating pieces of the Earth's crust, which are floating on top of the mantle. And what is a boundary? It means there is a point whereby they must be coming together, a point where they are coming together or where they are split. That is a boundary. Right. Then give the name of the geophysicist who first theorized the movement of tectonic plates. In other words, you are saying who is the father of plate tectonics, who discovered and who came out with the suggestion that plates are in constant motion, they are moving and they are divided into different segments. That was by Alfred Wegener. This is the physician who came out with the theory of plate tectonics. Right. We move on to the next question. Name the two plates responsible for the formation of the Rift Valley. The Rift Valley, where is it? You can figure it out on the map and be able to highlight the two places, the two plates which are moving away from each other, creating the Rift Valley. If you check on your maps, it was clearly indicated. So the two plates here is the Somali and the Nubia. Those are the two plates. What type of plate boundary is responsible for East African East African rift? We're looking at that Rift Valley. What type of plate boundary is a divergent boundary? Where two plates are diverging from each other, moving from each other, they give rise to the formation of rift valleys. Where they are colliding, they give rise to the formation of fault mountains. Right. Explain one positive and one negative effect of the African East Rift Valley for the people of Northeastern Africa. How are people of Northeast Africa going to be affected positively and negatively because of the Rift Valley? Right, on the positive, you can highlight that because of the Rift Valley, more fertile soil will form, which is beneficial for agriculture. If you have fertile soils forming, it also means there will be having favorable agricultural productivity. And also, minerals are brought closer to the surface. Because of the rifting, minerals which were hidden underground will become closer to the surface and it becomes easier to mine and extract them. So they are brought closer to the surface. It's another benefit. Then when we're looking at the negative, We can look at landslides. There is danger of landslide hazards. These are mass movements. Landslides hazards. It's a very serious challenge that can come because of the rift valleys. And also we can talk of lava flow hazards. What liquid rock can escape because now there is a rift valley which is forming, and that can give a rise to the problem of volcanicity in the area. Right, we move on to the next question, which is talking about pieces of evidence that support the theory that all continents were once joined as one supercontinent. Right, what evidence can we visualize which we can use to support the fact that these continents were initially one and then they got to split to form these current distinct continents? Right, you can talk about similar rocks along coastal lines. Those rocks with the same age along the coastal areas of different continents is one evidence. Or we can also say plant and animals which are similar. It suggests that those continents were the same. That is why we have typically the same plants and also the same animals on either side of some continents. All right, you can also talk of a jigsaw puzzle. If those continents were to be met together, they were to be pushed together towards each other, they could perfectly fit into each other, suggesting that initially they were once joined. So those are some of the pieces of evidence, though we cannot limit to that only. There are other pieces which are also very valid, which you can use to support the idea that the continents were initially joined together. It was one thing, but because of plate tectonics, they got to drift away from each other. They slowly moved away from each other. That is why now we have distinct continents on their own. But initially, the suggestion is, according to the geographical argument by the geophysicist Alfred Wegener, the continents were once initially joined as one super continent. Right. Then we move on to the next question. The next question is on folding and apparently faulting. Right. Identify the types of fault type labeled 1, 2, and 3. Right. Fault types 1 is here, 2 is here, 3. Right, what kind of a faulting is this one? If you check the nature of the forces operating here, you see this arrow is indicating that there is an operational force which is ultimately leading to the faulting in this area. So this is a divergent. There is divergence happening place there. Then at 2, if you check here, the arrow and the arrow, it means there's convergent. Then if you check here, the arrow is indicating that direction and that direction. They are sliding past each other, which we call transforming. So this is a divergent fault, this is a convergent fault, and this is a transformational fault. Right. Identify the parts of a fault labeled A and B. We go to our diagram where is A is here, A is here, and our B is here. This is a lower band of the fault, and this is the upper band of a fault. Right, the lower band, we call it a syncline. For A, it's a lower band, it's called a syncline. And then an upper band is called an anticline. So it's syncline for A, which is a lower band, and an upper band is an anticline, which is basically on top of the fault. Then name the mountain range in South Africa that developed because of rocks compressed to each other. Right, we have typically folded landscapes in South Africa in the form of the Cape Fold Mountain. We have the Cape Fold Mountain. That is the typically folded landscape in South Africa, which is evident of plate tectonics and the effect of folding and faulting happening on the Earth's crust. Right, number 2.44, differentiate between the process of folding and faulting. With folding, I think the name suggests the rocks, they bend under pressure. That is folding. It's actually bending. And faulting, the rocks, they crack under pressure. That is the difference there. Folding, we tend to force a rock strata towards each other and they bend. Faulting, they are being exposed to tension and they crack or they break along the weak lines of weaknesses. Right. Explain why C is considered as a symmetrical fold. C, remember we have what we call a symmetrical and an asymmetrical fold. Our C here, if we can draw a line along here, we can perfectly divide the limbs of fold C. This side is similar as this. Symmetrical meaning to say it can be divided into two equal and similar parts. So why is it considered it's symmetrical? Because both sides of the fold are similar. The both sides of the fold are similar. If something is like this, though it's not very perfect, but it's almost symmetrical, you can divide it and it can fold back and give close to the other side. But if a fold is like this is asymmetrical. We cannot divide this because this side is not the same as this side. But basically the limbs, if you check here, this limb is almost the same as that one. So this is symmetrical. They have a line of symmetry. The two sides are the same, but this is asymmetrical. There is no symmetry there. Right, then the last question, number 246, it says, explain the development of fold F. How does fold F develop? Right. When I'm looking at fold F, we need to check where fold F is and how fold F here. You are seeing that it's cracking along that line there. So it means in this instance, there is excessive pressure. Fold C develops. It develops when exerted pressure is extreme. The pressure which is exerted on either side of the fold is extreme to the extent that it does not only end with folding, it even cracks because of it cracks and slides on the other limb of the fold because of the pressure which is very extreme. Right, that is the last one. So we move on to the next question, which is number 2.5. Right, number 2.5 is talking about an extract on a recent earthquake in Turkey and Syria in 2023. Right. Define the concept epicenter. We can define an epicenter as in simple geographical point on the Earth's surface, which is directly above the focus. That is an epicenter. The focus will be inside the Earth's crust where the earthquake starts. But a point which is directly above that point where the earthquake starts on the Earth's surface is what we call the epicenter. Right. Then state the magnitude of the earthquake on the extract. You can check in the extract there. It's indicated the magnitude is M7.8 on the Richter scale. Right. List other natural disasters that may be triggered or caused by an earthquake. An earthquake can cause related natural disasters like tsunamis. If it happens in the ocean, it is going to trigger waves, which will lead to tsunamis. Or it can also relate to volcanicity or volcanic activity. It's another threat. And also it can cause flooding. And also there's danger of landslides. These are some of the related natural disasters that may be triggered by an earthquake. According to the article, explain how people may protect themselves during the shaking. According to the extract, we are looking at the extract here. During shaking, it is prudent to drop down on the knees and cover the head and neck using hands. This is what is suggested by. Then it also goes on to give us other measures that we can try to put in place to minimize the dangers associated with the shaking. Right, it says staying away from windows, furniture, or any loose structures. It's also another precautionary measure that we can take during shaking. Right, according to the extract, we have just extracted the information from as it is presented in the extract. Then in a paragraph of approximately 8 lines, discuss the reasons why the impacts of earthquakes will be more devastating in developing countries. Developing countries, we are looking at the third world countries, mainly African countries. Why do earthquakes have more impact here than in the developed world? Right, we are looking at in the developing countries, there's poor infrastructure. Because of poor infrastructure, even earthquake of a minor magnitude is going to destroy because the infrastructure is poor and is not maintained well. Then we can also talk of overcrowding. Like, for example, we can talk of informal settlements. If there's an earthquake in an informal settlement, it is going to damage more and destroy or even cause threats to the lives of many people because people are living in crowded conditions in the informal settlement, as an example. Then we can also talk of other things like poor medical care. A lot of people might end up dying because of poor medical care. And then we can also talk of disaster management, which is poor. Disaster preparedness and management is also poor. Like, for example, evacuation is not that effective in poor countries. Then we can also talk of other aspects like lack of advanced technology. And then when you're highlighting in the developed countries, you're just saying the opposite of what you were saying for developing countries. Developed countries have got the best infrastructure which resists shakes which resist even the shaking off, which is caused by the earthquake. Or you can talk of good medical care. They have the best medical care to attend to people who would have been injured during the shaking. Or disaster management is well in place and is fully prepared to cater with such natural disasters in developed countries. So we are basically comparing why it is to the detriment of poor countries to have more impacts of more negative impacts of such disasters than in the developed world. Right. That takes us to the end of our geomorphology question. Then after the geomorphology question, what you need to note there is you're supposed to attempt the map work question. So what I'm going to do, I'm just going to give you hints and tips on how you attempt some of the map work questions. Right. You're supposed to read the map information. It will help you in some instances in answering some of the questions. You must not ignore the map information. Then you come to map skills and calculations. Right. It says Emelo is situated in the Dash province. Like what I said, you must be able to figure out map information. It will help you to answer such questions because this information, if you don't know South Africa well, you might be unable to answer the question. You might not know where Emelo is in which province, but for this sake, Emelo is in Mpumalanga. That is our correct response. Right. And then the other question says a tourist will travel in a or n direction from Emelo to Johannesburg. What is the direction from Emelo going to Johannesburg? Right. We are understanding how those two provinces are related. As you are coming to Joburg from Emelo, we know Mpumalanga is in the extreme east of South Africa and Joburg is in the interior, which means you must be moving in a westerly direction. You're coming from the east going to the west. Right. What is the height indicated on the trig station in block D2? Right. Unfortunately, we don't have the map illustration here, but the clue that I must use there is if it's a trig station, it will be having two numbers. Let's say maybe there's 52 and maybe there is 102 4.3. Right, if you are seeing a trig station and it's got two numbers like this, the height of the trig station is this one here with a decimal. And then this is the station number. So do not confuse, the whole number is a station number and the number with a decimal is the height of that particular station. And also, if you are not very sure or you have forgotten, you can use other clues of height around the area. Like you can check the contour lines around. If there's any contour line that you can figure out around, maybe you see there's a contour line which is 1,000 meters. There's no way this trig station can be 52 meters, which when it's next to a height of 1,000. Automatically, it means 1,024 is the height of that trig station. Or if there's a benchmark around, maybe there's a road and there's a benchmark, or if there's a spot height around, use those ones to indicate, to check on the clue of the height. Right. Then calculate the distance in kilometers between spot height and the reservoir on the topographic map. You're just supposed to measure. You measure the distance between the two using your ruler. Measure straight line distance. And remember, our answer is supposed to be presented in kilometers. Your measurement distance, you multiply it by 0.5 kilometers. Let's say, for example, you measure, you get 3 centimeters. You multiply this 3 by 0.5. This is going to give you your answer in kilometers, because on a topographic map our scale is 1:50,000, which means if you want to convert your units to meters, you multiply by 500. If you want to convert to kilometers, you multiply by 0.5. Your answer will be in the right units. So if it's 3, for example, we're saying 3 by 0.5, which is going to give us 1,5. Our answer will already be in kilometers. So simply multiply by the map scale, and your map scale, you can summarize it in the sense that for meters from a topographic map, if you are calculating your distance in meters, you multiply by 500 meters. That is the 1:50,000. If you want to present your answer in kilometers, you multiply by 0.5 kilometers. Then you get your correct response. Right. Give the exact position of the wind pump, that is grid referencing using coordinate system. Remember, when you are checking on your map, the value for degrees, longitude and latitude is already given on the map reference here. You don't need to worry about this. They are already provided. It means your 23 is in degrees for latitude and your 29 is in degrees for longitude. And also the additional lines, they have got markings of minute lines. What you all need to do is to calculate the second position so that you are able to figure out your final response. Then it says how many times has reality on the topographic map MLO been reduced? How many times has reality been reduced? We are actually looking at the scale. Otherwise, the question is saying, what is the scale of the map? The scale of the map is showing how much reality was reduced. It was reduced to fit on a piece of paper, but by how many times? Then the topographic map is 50,000 times. That is the reduction that was used for reality to apply it on paper. If it is the orthophoto, your reality is reduced by 10,000 times. That is the difference in the scale between those two types of maps that we use. Right. We move on to the next question. Our next question is on map analysis and interpretation. We'll just discuss giving each other hints and guidelines on how you must be in a position to answer those questions. Right. We are saying in this instance, our question is saying the transport route to Pit Retrieve in block C5 is. You're just supposed to check on the map and see the transport route which is in that particular block given. Whether it's a national route or other railway, a national freeway or arterial route, you check and confirm with the map with this key of the map to see which nature of the road is portrayed by the route that you are seeing in that particular block. So you are able to figure out the correct response. Then to give an example of farming practice in MLO. Unfortunately, we don't have the evidence. You check on the evidence to see what actually is happening in that particular block. But it's much easier to check on the map. Explain the purpose of feature 6. Right, you just check the nature of the feature and confirm with the key of the map and see how it is used by people in that area. Then Kazim Park in blocks E1 and E2 on the orthophoto is located on a gentle slope. Provide evidence from the orthophoto map. Right, what you only check there for steepness of an area or for gradient, you just check the spacing. Check spacing of contour lines. Where they are far apart, it means it's gentle slope. Where they are closer to each other, it means it's a steep slope. That is the clue that you use if you want to check on the gradient of a given area. So it says it's located on a gentle slope. So automatically, it means the contour lines must be spaced further apart from each other to justify that it's a gently sloping landscape. Then also when you're reading your coordinates, like question 3 to 5, you're supposed to figure out how you determine your second values for latitude and for longitude to be able to locate the feature. Explain why the area of Wesselton appears bigger on the orthophoto map compared to the topographic map. We are comparing features on the orthophoto map compared to features on the topographic map. We are saying the topographic map is portraying the same feature as bigger than what it is on the topographic map. Orthophoto is portraying a feature as bigger than what it appears on the topographic map. The reason why it is like that is because of the scale. We are saying the topographic map is a small scale, whilst the orthophoto is a larger scale. So the reason here is scale on orthophoto is 5 times larger than the topographical map. That is why the features appear bigger, because the scale is larger than on the orthophoto, on the topographic map. Right. Then when you're checking the flow direction of a river, what you must check there is, if you see a river, maybe it's like this, and the question is saying, identify the flow direction of this river. Automatically, this river is going in this direction. Why? You check the angles at which the tributaries join the main river. They join at acute angles, which implies that this river is flowing in that direction. And you also check clues of height. If you see maybe there's a spot height here, which shows that this is maybe it's 1000. And maybe you see another spot height here is written 825. It means this area is higher lying and this area is lower lying. Our rivers must flow from high lying areas going to lower lying areas. And also check if there's a dam. For example, there's a dam like here. The dam is here, right? The river, it means if there's a dam like this, is flowing in this direction because of the position of the dam wall. The dam wall is to the side where the river is flowing towards. So those are some of the clues that you just check and see to figure out the direction of flow of a given river in any situation on the map. And that is also the evidence we have indicated that. Then we go to our last section, which is GIS. The first question is saying, define the concept geographical information system. I think it's a common term that we use. It's a computer-based technology for processing geographic data. For a range of uses. That is basically GIS. We are looking at using computers for geography studies. Either we are capturing information, we are storing information, we are analyzing, we are using computer technology to assist in the study of geography. Then any two components, the components we have, the major components of GIS, we have the personnel or the people. Then we have the software. We have the hardware. We also have the data. And we have specific methods that we use. Those are the components. Right. Then give an example, block D1 and E1, a natural feature, a line feature. Line features, we are saying the features are presented like that. For example, on the map, you can check, it can be a stream or a river. Those are typical example of line features that you can find which are natural on the map. Then you can also find out that you want a human-made polygon. A polygon feature is an area feature. It can be maybe cultivated land or cultivation. Or it can be, for example, a play field or a recreational ground or an excavation. It depends with the map. You check on the map, but those are some of the examples of human-made polygon features. Right. Then we go to the last one. Explain briefly why the orthophoto map can be classified as raster data. Why is it a raster data and not a vector data? It's a real image. Remember, orthophoto maps are made from aerial photographs. And on those aerial photographs, we add additional information like we add the names of streets, we add the names of places, we add clues about height, the contour lines, we add benchmarks, we add spot heights, those indicators of height. But actually, the basic thing about orthophoto maps is they originate from aerial photographs. So it's a real image. That is why it is in raster. And also it's made up of pixels. That is why it's a raster. Remember the difference between raster and vector. An orthophoto map is a real image. and it has pixels, meaning to say it was taken by a camera. And this vector here, we are saying it uses lines, polygons, and points to portray different geographical features on the map. For example, you can talk of the topographic map. It uses a vector data presentation, right? Then lastly, the other thing that I also want to add on the directional flow of a river, you also check the contour lines that cross the river, right? You see contour lines, they bend upwards as they cross a river. Like if you see a pattern like this, a contour line like this, then another contour line like that, then another one like that. It shows you that this river is coming from this direction, going that direction, because the contour lines, they bend upwards as they cross the river. So it implies that they are bending up here, so the river is going in that direction. That is the other clue that you use to determine the direction of flow of a river. Right. Basically, I think with that discussion, we have touched on some important aspects which will assist you in junior examinations, and also which will assist you in final examinations paper 1. Remember, your paper 1 will be based on the very same topic of climate and also geomorphology, inclusive of your section B question, which is a map work question. So I think as you go through the discussion, you can get to understand one or two aspects, or you can get to figure out and correct yourselves where you were missing some important aspects on geography. And in as much as passing is a basic requirement and a purpose for learning, it can only be achieved through constant revision. You must always remember to revise and reinforce concepts in your mind. The more you revise, the more you get to familiarize yourself with the geography questions, and it will also assist you in better understanding of the concepts.